Okay, let's do general formula. Derivative of differentiation by general formula. I believe we've done the one for what we call first principle, right? We've done differentiation using first principle. I taught you everything that I need to teach you on that, right? So this time we use general formula and the same questions. I'm using them for the same questions, so it'll be easy that way for us to work with. Right, so shout out to everyone that has been supporting my channel, Premium Academy. Thank you guys. I really appreciate it. Let's look at this because of time. All right, so number one says, I thought before we even start, what is general formula? How do we apply a general formula to solving differentiation? How do we differentiate using general formula? Is that easy? Right, so if we have, for instance, we have stuff like, let's say we have x raised to power n as your y is equal to x raised to power n. Let's just assume this is the function given, right? And we're asked to find dy dx. Is very simple, very easy. What we'll do is by saying our dy over dx will be what? What is here? We multiply the constant number here. This n will multiply what we have here. And we know we have nothing here. So it's just going to be n, put n, and put the x, and then we use the n minus 1. That's all. There's nothing there. Right? To differentiate, this power will multiply. There's a constant number here. Power will multiply it. I will subtract 1 from the power. That's all about that. That's as easy as it gets. This is the formula for it. Right? So it's very simple. It's very simple. As a matter of fact, to me it's like we're using this this formula, this principle to check our answers for first principle. Because first principle is actually long. Right? We've taught first principle about 2 months ago. That's done at a longer scale. So we're using this one just to cross-check our answers, right? So for instance, we have, let's say for instance we have if y is equal to let's say 2x raised to the power of 4, what would dy dx be? Dy over dx, our derivative becomes what? This 4 will multiply this 2, that will be 4 times 2, right? Our x will remain x, and we'll subtract 1 from 4 minus 1. That's just all. I don't think there's anything there. So we'll have our dy over dx as what? 4 times 2 being 8x raised to power 3. That's a derivative. And we have different type, right? This is just the first derivative. We can derive, we can do second derivative, third derivative, fourth derivative, fifth derivative. It's as far as we want to do, depending on the power we have. And this is just a first derivative. Simple, very simple. I said if we have, they'll give us the function. What we'll do is to use what we have here to multiply what's here and subtract 1. So for instance, we have that y is equal to ax raised to power, let's say n, right? What would dy dx be? Dy dx, that's our derivative, will become n times a, or a times n, and then x n minus 1, in case you have a constant number before it. They are both the same thing. Just use this n to multiply the a and subtract 1 from n, right? Haven't done this. Let's use that to see how we can run this one down. We did everything here using first principle. Let's use this now, doing it by checking using general formula method. See you in the next video, guys. Thank you. Alright guys, let's start with a constant, just constant numbers, right? So if we're asked to differentiate a constant number, we will get 0. And we'll prove it. Let's show the proof for why if we differentiate a constant number we'll get 0. Constant number means just single numbers, right? And constant number is a number that nothing is attached to, constant variable, right? So look at now, it's just 5. In actual sense, this is actually 5x raised to the power of 0. The reason is because 5x, anything raised to the power of 0, this x raised to the power of 0 is 1. Anything raised to the power of 0 is 1. I've taught you this a number of times. So it is actually 5 times 1. And 5 times 1 will give us what? Will give us 5. So this 5 you are seeing is in real sense 5 raised to power x, 5 times x raised to power 0. Because we are differentiating y with respect to x. Are you getting? So we reveal what is hidden. I'll show you this as we deal with other ones, right? I'm just trying to show you how it works. That every single variable is actually the number times x raised to power 0 if we are differentiating with y with respect to x. Are you getting? So in doing this now, if we have this, if we have reviewed this, our dy over dx becomes what? Becomes this 0 will multiply what we have here. I told you now. So it becomes 0 times 5. And then we have x. Let me just bracket this, right? 0 times 5 first. Then this x, which is this, which is this x. raised to the power what? 0 minus what? 0 minus 1. Are you getting it? Yeah. So because we know that the power must subtract 1, so we have 0 minus 1 to fulfill the condition. Knowing that we have dy over dx becomes what? Is equal to 0 times 5 is what? Is 0 x raised to the power minus 1. But 0 times this is still 0. Are you seeing? So if we differentiate a constant number, we'll get it 0. 0 times everything will give us 0. Therefore, our dy over dx, the constant number is 0. 0 times this is 0. 0 times anything is 0. Are you getting it now? So note this, just note it down. Note that the derivative of any constant number, right, is equal to what? To 0. Any constant number at all. If you have a constant number by derivative, if you take derivative of it, you get 0. Right? That's the first thing I want to establish. So let's get to number 1 now. Let's do number 1 to 5 on this. And then I give you some exercises for you to work with. See you next video, guys. Thank you. Alright guys, let's look at this now. We said we should do the derivative of this. Y is equal to 3x plus 6. It's simple, right? I said, look at this now. This is x now. It's a constant variable. It has an attachment, right? This s is raised to the power of 1. Every single number is raised to the power of 1. I told you should know this by now. And this 6 has what? X raised to the power of 0. So let's just reveal everything. This is the question. Our solution will be that we have y is equal to 3x plus 6. Let's review what is hidden. This x is raised to the power of 1 and this 6 has x raised to the power of 0. Every constant number. Right? So we'll start using the power to multiply the constant here. 1 times 3 and 1 minus 1. 0 times 6 and 0 minus 1. So let's go. We have this. Our dy, doing that, our dy dx becomes what? 1 times 3 and this our x. Let's just bracket this. And our x, which is this. Then this 1, we subtract 1 from it. Right? That's the first one. Plus this 6. 0 times 6. 0 times 6, let's put a bracket on that, and then our x 0 minus 1, 0. Try to understand what we're doing. Please follow. If you don't understand, leave your answers, leave your questions on the comment section. We'll get to all the questions. In doing this, we have that our dy over dx gives us what? 1 times 3 will give us 3, right? And x 1 minus 1 is 0, plus what? 0 times 6 is 0. Okay, let's just take it slowly. 0 x minus 1 plus 0 minus 1 is minus 1. But we know that 0 times this x minus 1 is 0. So this is a constant number. We should know it's 0. We've talked about it. Everything here is 0. What becomes the final answer? Final answer there becomes anything raised to the power of 0 is 1. Right? So we have 3. This x raised to the power of 0 is 1. So it's 3 times 1. Because we know that any number raised to the power of 0, this x raised to the power of 0 is 1. So it's 3 times 1 here. This 0 is gone. Our dy over dx is simply 3 times 1 plus 0, which is 0. We'll have 3. So our answer. Very simple. Just look at it. If we have just one variable with the power raised to the power 1, the answer is basically simply this. So if we have that y is equal to 4x plus 4, you should know that dy dx, since this is raised to the power 1, our answer is just 4. Right? Just in if we have a given an equation whereby we have to derive raised to the power of 1, you should just know that if the x is power 4, if the unknown, the one we are differentiating with respect to is raised to the power of 1, the answer probably is a constant number, the coefficient of that number we have there. Our answer is x. So knowing fully well now, knowing this by following this step, if I say y is equal to let's say 8x, right, and we're asked to find dy dx, you should know that the answer should be what? Should be 8. Very simple, because it just has a single attachment, right? I hope this is clear. And let's leave this one and get to question number 3, right? See you next video, guys. Thank you. Alright, so looking at this should be easy. Alright, we know what we're targeting. If we are differentiating this, we have that our dy over dx, the way of differentiation, becomes what? These two multiply this 3, right? 2 times 3, which will give us 6, Just going straight to the answers, right? And then our x will remain. Then we have 2 minus 1, right? Yep, 2 minus 1 minus what? 6. We have raised to the power of 1 here. So 1 times 6 is 6x, and the 1 here will minus 1. I should not be doing this. You should know this by now. And then we have an x raised to the power of 0 here, right? So it is plus 4 times 0. That will be 0 times x raised to the power of 0 minus 1. It's very simple. This originally we know is 0. Everything here is 0. So 0 times everything is 0. Let's focus on this. The y over the x becomes what? Look at this now. 2 minus 1 should be 1. So we have 6x raised to the power of 1 minus 6x, 1 minus 1, which is 0, to the power 0. Right? And anything raised to the power 0 is 1. So our answer becomes, just take here, our answer becomes 6x minus 6. Simple. Because if this raised to the power of 0 is 1, 6 times this one is 6. And this is just 6x raised to the power of 1. Therefore, our dy over dx is simply what? 6x minus 6. The answer. Very simple. It's not hard. Right? Just look at them and then you know what to do. Simple. Simplest thing you can do. Well, I know it's going to give you issues when we are doing first principle, of which I explained extensively. I'm still going to be explaining. Maybe after this class, I'm going to be doing a separate video on Pascal's triangle to see how we can help broaden our understanding of what we're doing. But let's leave that. Let's face it. Right? Let's look at the next question. In doing that, look at how to solve this. Right? You do this one. You guys should try this. I've done this. I know I'll do this. You try this. Let me do this. I'll do this one. I'll do this one, and then I'll leave you guys to do this one, and then we'll compare using the value we have for first principle. We'll solve everything using first principle. We're just trying to correlate using this. Right? See you in the next video, guys. Thank you. All right, here's the final question we're doing for this session of differentiation. Right? It's very simple. We know what to do. If you watch carefully, you see that the powers are decreasing in descending order. 3, 2. This one is raised to the power of 1, and this one is x raised to the power of 0. That's the secret. You see, the powers are decreasing from 3 down to 0. Right? That's what they don't show you. They won't show you this in your exam, in your textbook, but this is Polynomial Academy, where you get every package. Right? Alright, so let's go. So we have solution. Our solution becomes that our dy dx by differentiating becomes what? This 3 will multiply this 4. So 3 times 4 gives us what? 12. 12x 3 minus 1. Right? Then plus 2 times 2 gives us what? 4x 2 minus 1. And then minus 5 times 1 gives us what? 5x 1 minus 1. And then this we have plus 3. And this is raised to the power of 0. Everything here is 0. Every constant number is 0. We've done this countless times. That's 0. That should be gone. So our answer dy over dx becomes what? 12x raised to the power of what? 2 plus what? 4x raised to the power of 2 minus 1 minus what? 5x raised to the power of what? 0. We know what we said now. Our answer, our dy over dx becomes what? 12x squared plus 4x minus 5 as the answer to that question. See how easy it is. For the order, we've been doing this quite some while. Right, so but in case you don't understand, you still have duties, you still have questions. And just go to the comment section and leave your question there. Sure to give you all the answers you are looking for. Very simple, right? Let's jump to the next kid of questions we have. Let's try and solve questions fractional questions on differentiation. Let's look at fractional questions on differentiation.